Hello, my name is John Greiner with Basin Safety Consulting and Training, and this month we're going to be covering Hazcom, or Hazardous Communication, Globally Harmonized System, or GHS, and Benzene Awareness Training. So first we're going to be covering Hazcom, and we have a few basic objectives here. First of all, what Hazcom is, how to protect yourself from hazardous chemicals, knowing how to use the Emergency Response Guide, or the ERG, knowing how to use the SDS, as well as understanding that you have the right to know what chemicals are in your workplace and how to protect yourself as per OSHA. So getting into Hazcom, this is not necessarily a dangerous goods course or a handling necessarily or even transporting. This is just basically what OSHA wants everybody to know regarding the hazardous chemicals in their workplace. So it is the communication of those hazardous chemicals. It includes labeling, it includes how to handle them just a little bit, as well as how to identify the hazards just by looking at the label, as well as just knowing the negative effects they can have on the people handling them, working around them, or the environment. And a big part of that is making people sick and essentially not going home or not being able to come to work the next day. And that's really what we want to prevent. So as far as GHS is concerned, this is a relatively new program that started in 2014. It gives you the right to know about the chemicals from a global perspective. So even if you got shipped a barrel from China of a certain type of chemical, that you could look at the label, even if you couldn't read all the words, and be able to recognize, hey, this is toxic or this is explosive, and kind of give you some direction on what to do about that, based on your company requirements. So it gives you the right to know based on the type of work you're doing, as well as gives all chemical manufacturers and transporters kind of gives us a standardized method of communicating to the people that are going to be handling the chemicals what they should be looking out for. So part of the Hazcom programs, as I mentioned, labeling is a big part of that, as well as having a written program, having a chemical inventory at all times, like all the chemicals that you have, as well as SDS information, so that you can look up, if there's a spill, how to clean it up appropriately, if it gets in your eyes, what the best thing to do is on your skin, etc. If you inhale it, what the proper methods are of mitigating that, as well as labeling, SDSs, and training the employees. It all kind of links in together. So as far as the written program is concerned, company needs to have a written program. It's going to talk about what chemicals you have in the workplace, where they're stored, how to look at an SDS, where your SDS books are, etc. It should be available for your review. They need to train you on it, and that's kind of what we're doing here today, is giving you kind of the general guidelines of Hazcom, as well as specific training for your workplace. So for example, we're not going to cover if you're dealing with a chemical like acrolein or anhydrous ammonia, but we will talk about that a little bit. But we're not giving you specifics. We're just kind of giving you the general information, as well as how to protect your employees from those hazards. These should all be in that written program. So companies need to keep all their chemicals in one database, in one inventory list, or in one book, and make that available to employees. A lot of companies have gone to using an electronic database that's in a cloud somewhere, so you can click a link and see all the chemicals that you have on site. That's not required though. You can have a printed out book, but employees need to be able to have access to the SDSs within a reasonable period of time if they're working around those chemicals. So for example, you don't need to carry one in your truck with you if all the chemicals are stored at your workplace, or at the shop. However, if you carry chemicals with you, such as diesel or methanol or something of that nature, then you need to have the SDSs of those chemicals available to you wherever you are. So that's why a lot of companies have opted for the cloud version, so you can look it up on a phone. So when new chemicals come in, we need to add them to the inventory. Employees then need to be trained on those chemicals and how it's going to affect your body. What if it gets on your skin? It needs to be stored over here because it's flammable, away from heaters and electrical systems, etc. And then also, if a contractor is bringing a chemical into the workplace, let's say they're coming to do some cleaning or something, then you need to be trained on those chemicals as well. So that can get a little bit complicated and difficult, but that is the standard. So as far as labeling is concerned, they need to be labeled appropriately. There's a few different basic requirements here. One is that there's a pictogram on it, and those are the little diamond ones. There needs to be a signal word, a hazard statement, and precautionary statement. So typically your signal word is going to be danger or warning. You can't have both. It just needs to be one. A hazard statement is essentially, like flammable, or don't, mix with water, any kind of hazard statements. And then precautionary statements are a little bit more basic. They're like, do not store, below 80 degrees. It's just, this is a requirement of dealing with this chemical effectively. So every chemical that's shipped, even if it's shipped across town from your store to another site, it needs to have a GHS label on it. And secondary containers must have labels affixed as well. So if you put, let's say you get a 55-gallon drum of citrusol or citral cleaner. If you put that into a smaller spray bottle, that smaller spray bottle also needs to be labeled. And it can't just say citrusol or citral. It needs to actually have the pictogram, the precautionary statements, etc. on that label. So here are all the pictograms. There's 9 of them. The only ones that people typically have trouble with are the irritant with the little exclamation point and the health hazard. A lot of times people, when I just give them that blank without any description, they would say, oh, it's harmful to the lungs. Well, it's basically harmful to the whole body, and that's why you see the body with a kind of star-shaped image in it. A little confusing, but that's just general health hazard. The O with the fire means oxidizing, or that it reacts with oxygen. Flammable is pretty straightforward. Explosive, that one's also a little bit complicated, but when you see something exploding, just think explosive. Compressed gas has that cylinder on it. The dead fish and tree, that's dangerous to the environment. And obviously the skull and crossbones means toxic or harmful to the body. And then corrosive is, essentially eating through pipe or burning up the hand. And that's kind of the 9 pictogram, GHS pictogram suite. So there's some other labels that you can add to chemicals as well, and sometimes you have to, depending on where you get them from. So in this case, we're looking at an NFPA 704 label, where it kind of gives you some descriptions through a numerical system on a diamond. And there's 4 parts to this. The one is reactivity. Then you have fire or flammability hazards, health hazards, and then any specific hazards such as acid, don't mix with water, it's radioactive, it's an oxidizer, or whatever. And that would actually be kind of spelled out, or you'd have that image to it. And then it goes in from severity from 0 to 4. So 0 being least hazardous, to 4 being highest hazard. And so here's kind of the list of the numerical system and kind of how they determine which number is affixed to it. And this is all information you can get from the SDS. So even if it doesn't have this and you want it, you can read through the SDS and create your own. Pretty straightforward. So this is typically used in Canada. It's also a GHS kind of specific hazard, and this one deals with PPE. So this, for example, if the chemical says C, then you're going to need protective eyeglasses, gloves, and some sort of apron. But if you get down there to K, you're dealing with breathing air systems and a specific type of clothing, full body gear, just the whole 9. So it has, you can read through it, and typically chemicals can come with this if they're coming from Canada, but if not, once again, you can create this as well, depending on the kind of chemical that you're dealing with. So the alternative labels are designed to help emergency responders mainly. If they haven't been trained on that chemical, but they're there to clean it up or rescue somebody from it, they need to be trained or they need to have a quick access to information about that without training. So it doesn't replace the GHS label, it's just an additional. And chemicals with containers that are transferred will be used immediately, and if they do not, then in that case they do not need to be labeled. So for example, if you're transferring a chemical from a large drum to a small container and you're using, like, let's say a funnel or something, or a smaller container, you don't need to label that when you're using it, as long as you don't store any chemicals into that drum or barrel or spray bottle. So there's also something called a UNID number, and this relates to the Emergency Response Guidebook, or the ERG. So these numbers are typically used during transportation, and they give specific data about what chemical you're dealing with and what the hazards are associated with it. And this is for emergency responders, or every truck driver needs to have one in his truck if you're a DOT driver. And so, for example, on a 3082, 9, it doesn't mean anything unless you're really knowledgeable about every single chemical out there. It's just now, that's just a random number. But when you look into the ERG, you can look at it by number. Also, you can look at it by chemical name, and it's going to give you requirements. So, for example, if you're transporting H2S or anhydrous ammonia, they actually have a similar requirement. It's going to say, hey, if there's a leak, get people, a mile away or an eighth a mile away immediately. Don't go in there without a breathing air system or a CBA. Don't, bring anything flammable nearby, etc. Whereas, if you just run into a situation not knowing what chemical you're dealing with, you can get into a pretty bad situation pretty quick. And we're going to watch a short video here in a moment that kind of shows that. So the yellow section is under the UNID number. The blue one is by the chemical name itself. The yellow and blue sections will take you to the guide, and the orange section that gives guidelines on how to respond. So it's going to kind of tell you this is this chemical, anhydrous ammonia, for example, yellow and blue. And then the orange section is where we're going to look at distances for evacuating personnel, what PPE to wear, etc. And if a chemical is especially dangerous, it's going to be highlighted in green, giving those isolation distances, fire protection, etc. So that's pretty much how to use an ERG guidebook. So here we're going to get into an instance, kind of a realistic possibility, especially for those of us who live in North Dakota and Montana, of an officer who came upon a situation where he was responding to an accident. There was a vehicle accident, and I'm going to zoom ahead here a little bit. So he's responding to this vehicle accident, and as he's pulling up here, you can see obviously a person who's unconscious in the road, a cloud coming out of a tanker here that's being pulled by a pickup truck, and it's kind of shifting direction. And one thing we all need to know about wind direction, because we talk about it especially around H2S safety, like look at the windsock, but wind direction can shift and change, and you'll see throughout this video how many times it can shift and change, even if it is, one time relatively consistent in one direction. So if you're like me, when you go out and you're at a campfire or something, and the smoke just keeps kind of tracking you no matter what side of the fire you sit on, you have to move 8 or 10 times while you're trying to eat your hot dogs or your s'mores. And you'll see that here. So this individual, the officer went to the individual, tried to kind of shake him and see if he was okay. He was unresponsive. And about that time, he realized, oh snap, like I'm not breathing very well. I'm having respiratory issues, and it started running back to a squad car. Got about 3 steps, barely, before he was overcome by the chemical here and lost consciousness as well. And so he's there breathing on the road. So I'm going to track forward ahead a little bit here. But as you can see, the wind direction continues to shift. It clears up here for quite a while, actually, as the ambulance shows up. The first responders start to get ready, and they don't know what this chemical is, so they're making wise decisions here. They're getting suited up. They're putting on their SCBAs. They're getting their water system ready to fight back that cloud. And then they go in, and now they attempt to perform rescue with all the right equipment on. So these guys are perfectly fine. You see someone over there getting the person out of the car. They're perfectly okay. But they're having to rescue. They're kind of having to choose who to rescue first in this situation, and that's kind of the position that the officer put himself in, as far as running in without the right equipment on. So if you're not trained, or you don't have the right equipment, or you're not looking at that ERG guidebook, this could be any of us if we want to go help. Because our first instinct when we see someone in trouble, and this says a lot about humanity, is to go help that person. I'm gonna get them out of harm's way. But without the right equipment, you actually end up putting yourself and that person into more harm's way, because then they have to make the decision of who to rescue first. So unfortunately, in this scenario, the 2 people on the road were overcome by their injuries, and they did expire. Moving on to our next slide here, we're going to talk about SDSs a little bit, and this is it does give some information as far as response, and what to do in the event of a spill or a leak. What PPE to wear, how it's going to affect your body, the toxicological effects, etc. And it is an integral part of the chemical inventory program. So obviously you're going to have your list of chemicals, but then each of those chemicals needs to correspond to its SDS sheet. They give specific information, best source of information about a chemical, and they were formerly known as the MSDS, but I call them both. Probably a lot of you still call them both. So Either way, MSDS, SDS, but most of them now are required to say SDS. So there are 16 sections to an SDS. Obviously, the length is going to depend on the hazards of that chemical. It needs to be in an accessible location to employees, usually around where your chemicals are stored or people are working around them, or as I mentioned before, they can be on the cloud. They're required for all chemicals on the job site, at your shop, at your office, if it's Windex under the sink, if it's citrusol, if it's oil, gas, gasoline, methanol, anything, you need to have an SDS for that. And the sections, 1 through 16, you have identification, hazards identification, what color it is, what it's going to do, is it flammable, combustible, composition information and ingredients. Sometimes in this section it's not complete, and typically that will be for intellectual property reasons. They don't want to tell people what their ingredients are. There's still some lawsuits out there and court cases dealing with that, but as of right now, sometimes that will not be complete. However, first aid measures will be, firefighting measures, accidental release, what to do if there's a spill, handling and storage, exposure controls and personal protective equipment, physical and chemical properties, that's going to deal with how heavy it is, how it, is it lighter than air, heavier than air in its vapor form, stability and reactivity, toxicological information, or how it affects the body, ecological information, how it affects the environment, disposal, how to get rid of it, how to transport it, what regulatory information or requirements are out there, and any other information such as, when it was prepared, when the last SDS was revised, etc. That's kind of all the sections of an SDS. So training, you do need to be trained specifically with each chemical. Now, if your company uses, basic chemicals, cleaners, household solvents, things like that, you're not going to need to have an in-depth, 40-hour training class. However, if you're dealing with hazardous chemicals or chemicals that ignite or are flammable, then you'll definitely want to have some specific training. Like, hey, we need to store this in this cold storage area, or we need to make sure this is an area that's well ventilated, or that we have this PPE when we're using it, and then have some hands-on training. And typically, a HazWOPER course will cover this. So the 8, the 24, the 40-hour deals with hazardous waste operations and emergency response, because we hope an accident or an emergency doesn't happen, but we do need to be prepared in the event of one. So it's going to cover, like I said, all those different areas of how to deal with it and to deal with the different chemicals. And this is vital. If you have not been trained on a certain type of chemical that is either really toxic or flammable or reactive, definitely ask for some training. We can help with that as well if it's something that's kind of out of the norm, or more hazardous than you feel comfortable with. In conclusion here, hazardous chemicals can be at your work or at your work site. You definitely want to make sure you know the SDSs for those chemicals, kind of understand the basics, have that ChemTrek number, which is the emergency medical number if it gets on someone's skin, eyes, or they digest it. Make sure you're properly trained to work with chemicals and that they're labeled appropriately, and never respond to an emergency that you are not trained to handle. I cannot stress that enough. All right, so dealing with a specific chemical this month, we're going to be talking about benzene. So this is an awareness training course. It's not a handling course or how to specifically work safely around benzene from an operations standpoint, but more so just kind of the hazards associated with benzene. So we're going to be covering how to protect yourself from benzene, exposure limits of benzene, what PPE you need, routes of exposure, and then how benzene can affect you. So that's going to be kind of our objectives here today. So benzene is a colorless liquid that has a sweet smelling odor. In fact, we'll get into this a little bit later. They used to use it actually for aftershave because it had a sweet smelling odor. So in the 30s and 40s, if you were trying to meet the ladies, then you'd probably have had some benzene aftershave on. Don't use it that way anymore, but they probably learned from the high cancer levels they were experiencing from people who used it. It is a common component found in crude oil as well as refined petroleum products such as gasoline, and it's also found in substances like volcanic emissions and cigarette smoke. So it's known as C6H6. It's a carcinogen, meaning it causes cancer, specifically leukemia, bone cancer. It can cause bone marrow abnormalities. That's the kind of the part of the body that it affects mostly. And as I mentioned, in the early 19th and even 20th century, it was used in many aftershaves because of the sweet smell. So flammability, it is flammable. So proper storage and keeping it away from ignition sources is important. The LEL is, essentially about 1.8%, which is extremely low for chemicals. Usually they kick off around 4%, meaning that only less than 2% of the air needs to be mixed with benzene vaporized in its vapor form for it to ignite. And upper exposure limit, this is also relatively low, is 7.9%. After that, it's too rich to burn. Below that, it's too lean to burn. So as you can see here, acetone, ethylene, ammonia, methane, and hydrogen. I mean, hydrogen's probably, hydrogen and acetone are the only ones close. Ethylene a little bit from the UEL, but the LEL perspective, it's definitely probably the shortest range here of most chemicals. So exposure, as far as where we're going to be exposed to it, inhaling it is most common in our industry. So near thief hatches, by treaters, flares, even near the wellhead, etc., is possible. If you're hauling crude oil or salt water, it can be in the air with the vapors from those as well. And it can absorb into the body after contact with those chemicals as well. So what's going to happen when people are exposed to this is, in addition to the blood or the bones have an issue, you can have blood disorders, headaches, nausea, convulsions, loss of consciousness, and ultimately cancer, because it is a carcinogen. So workers must be protected from it. The PEL is 1 part per million, which is really low. Even for H2S, it's 10. And the short-term exposure limit, or basically 15 minutes to 20 minutes during a work shift, is 5 parts per million. So, and the PEL is regulated over an 8-hour shift. So API recommends that there's no safe exposure limit for benzene. Benzene is not a great chemical. It doesn't, instantly kill you, such as hydrogen sulfide will typically, but even at lower concentrations, it can really, make you sick over time. So for any chemical, and benzene especially, we definitely want to have a plan. So what PPE do we use? And we'll get into that in the next couple slides. What safety measures do we have, engineering-wise, administrative? Do we have signs? Are we monitoring people? Are we testing them to make sure that their blood's in good shape? And then obviously when people are exposed, we need to maintain information about them. So ventilation is huge, just like any airborne contaminant. Limiting access to places that workers could be exposed to benzene. In the oil and gas industry, a lot of well sites now have remote gauging systems, for example, and that prevents people from needing to go on top of the tanks. And that's both for hydrogen sulfide as well as benzene. Training workers that are going to be working around it. Hey, this is a hazard. This is just like we talked about in Hazcom. People need to know, like, hey, you're going to be exposed to benzene. Here's what could go wrong, and here's what we're going to do to fix that. And workers also must be trained before they can work with any hazardous substance of any kind, so benzene definitely falls in that category. So communication, labeling, as we mentioned before. So signs, warning labels, GHS labels, and SDS sheets must kind of be available to workers at all times, and on anything that contains benzene. So the signal word here is danger, not warning, and danger is worse than warning. It's a carcinogen, cancer-causing, flammable, and authorized personnel should only be working around it. And then if you are working around it, you're definitely going to need a respirator. So there's different types. There are cartridge type or air purifying types that you can use, but above the IDLH, which I believe is 50 with benzene, you're going to need, 100 parts. You're going to need a full face piece air supplied respirator or an SCBA. So for skin contact, just wearing chemical resistance gloves, sleeves, boots, and aprons will work. Chemical goggles and a face shield are recommended. And if there is an exposure, you definitely want to wash the eyes out in the emergency shower station or the body for 15 to 20 minutes. So how do we test for benzene? Typically it's done in 2 ways, through badges or charcoal tubes. I got a picture of that here. The badges are just, little, they have little membranes on them. You face them outwards away from the worker. And then over a period of time, it's going to collect, air and benzene or any other type of contaminant. At the end of the day, we seal it up, put it in a bag, send it to a laboratory, and they'll say how much you've been exposed to, or through passive collection beakers. So what we'll do is we'll put a glass a jar, it looks like, up at the top of a tank or behind a treater, wherever guys are working. We'll have an inlet valve open over 8 or 24 hours. Just let it fill with whatever air passes by it. It's going to fill it up. We'll send that to a lab, and they'll use a gas chromatograph to test that. So it's going to separate any liquids and then test what's left in the air as far as gas goes. These are typically plans designed by industrial hygienists, which are degreed individuals in this type of work. It follows NIOSH 1501, which is the National Institute of Occupational Safety and Health, and it's just going to let people know how much benzene they're exposed to over an 8-hour period. So just like H2S testing that we went over last month, you can break the two ends of these tubes, pull it through your pump, and it'll fill that gel silica in there with a contaminant, and then we can send that into a lab and determine exactly how much benzene you've been exposed to over the period of time that we were testing. So wrapping up this slide, always wear your PPE. Benzene can make you very sick. It can be found in petroleum products, and you always want to make sure you're protecting yourself if benzene can be present. So we talked about this last month as well, and just good to know. We've definitely seen some people posting this. If you post on our Facebook, give us a like and a comment, or on Google, we actually take those names, and at the end of the year we do a drawing for a shotgun. We also have some $50 gift certificates, or a shotgun, or an equivalent cash award if that's what you choose. So definitely put your name down there if you want to get entered in for the drawing. Show us some love. Let us know how we're doing, and we really appreciate you being a part of this month's training. And we'll see you next month.